Alright, this is exercise 6B on the division of polynomial functions. It is on page 215 of your textbook. So polynomial division, these notes are actually from the booklet that I gave you at the start of the year. It's a process of dividing a polynomial is similar to numeric division. Now I know it sounds really dumb to go back all the way into what we call long division, but we're going to go ahead and do that. So in this process, I've got the dividend, divisor, quotient, remainder. Right now, those terms aren't entirely important per se. I'm focusing on where are the numbers and how do they interact with each other. In this case, I've got 37 divided by 5. You guys are all familiar with that escape route thing. I'm saying what number goes into 3, obviously none, and then what number goes into 37. And so you'd say 7, right? Because you're saying 7 times 5 into 37. So basically, all I want you to think about is whatever number right on the top, that's the number I multiply by my divisor, which is obviously this one right here, by my divisor, in order to get the number closest to the dividend. Does that make sense? Yeah? Awesome. So that's that multiplication that I'm focusing on. And obviously you guys know that whatever we get in the end is the remainder. And that remainder is smaller than the divisor. Easy? Great. So in this case, we would all agree that we can say 37 is the same as 5 times 7 plus 2. Can all agree on that? Easy. And that's because we're going ahead by using this one over here. So 37 equals to 5 times 7 plus the remainder over here. And the reason I'm bringing us back to this numeric division is because it applies to numeric division, polynomial division as well. In this case, and I'm going to read the sentence underneath, it says, polynomial division similarly focuses on the leading terms of dividend and divisor. This can be written as P of x equals to D of x times Q of x plus R of x. All that's saying is that the original polynomial is the same as my divisor times by my quotient plus my remainder. Are we okay with those letters there? Yeah. And the only reason I'm saying D of x times Q of x plus R, instead of just saying DQR, is because we've got variables involved. So it's no longer just a number. It might be, let's say, it might be a x squared or x minus 1 or whatever it is. So we're working with algebra. In other words, how do we divide using linear or monic divisors or whatever it is? I'm going to actually go ahead and do examples because I feel like this is really comes down to practice. I know I say this a lot, but it really does come down to practice. So when I look over here, I've got 37. What you would normally do is you'd say, well, what's 5 times 7? 35. So you know instinctively you take away. We all know that, yes? We've done long division, right? This is not the generation that's never heard of long division, right? Can you put your hand out if you've done long division when you were younger? Okay, thank God. Okay. So, I'm going to do the same thing. I'm going to take it really slow. I'm going to do the same thing with this. So if I'm dividing x squared plus 7x plus 11, that's my first function over here, by x plus 2. What goes on the inside of the escape ramp? Yeah, the x squared one, right? So I'm going to write x squared plus 7x plus 11. That's right, I call it the escape ramp. It's a very mathematically official term. And I'm dividing by x plus 2. So what I'm going to do, I'm going to focus on the first two terms. Oops. X squared plus 7x. What do I have to multiply? Because remember, the idea is I'm trying to cancel out this. So what do I have to multiply x plus 2 by in order to get the leading term to be x squared? Just x. So I'm going to write x on top. Now I multiply this by x, right? So what's x times x? X squared plus 2x. Good. Once again, in this line, are we adding or subtracting? We're subtracting. So I write, you don't have to do this. This is just so I can remind you guys that we're subtracting. For some reason, a lot of people do addition. We're subtracting, so I'm going to do this. Are we okay with that? So remember, when we're subtracting, we're not just subtracting the first term, we're subtracting the whole thing. So from there, I can say x squared take away x squared gives me nothing. So I get 0. In the next column, wow, there are so many house captains in this room. What can I say? I breed leaders. Anyway, so 7x take away positive 2x. What does that give me? 5x. Good. Now in long division, I still have the plus 11. Caitlin, can you close the door for me? Thank you. I still have the plus 11. What do I do with that plus 11? In long division, I would just bring it down. So I'm going to write plus 11. So that's from over here. Can you guys see that off the back? Yep. So from there, same thing. What do I multiply x plus 2 by in order to get that first leading term to be the same as this term here? 5. Positive or negative? Positive. So I'm going to write positive 5 over here. Now, same thing. I'm going to write x times 5 is 5x plus 2 times 5 gives me 10. Have I lost anyone here? We'll go through another example afterwards. Like I said, it is quite complex. So, I'm going to take away, subtract. What do I get, Zach? Just 1. So, can I go any further? No. So, what I can say is I know that my original equation of x squared plus 7x plus 11 is going to be the same as this multiplied by this plus this. Does that make sense? Yeah. So it's just like long division, but with algebra. So I'm going to say x plus 2, x plus 5, plus 1. If you were to get your calculator, expand that, or you can do it by hand, and then add 1, you would get this original equation. I'm going to go through one more example, and we'll see how we go from there. Similar idea, divide 3x cubed plus x minus x. The only difference is in this one, we don't have an x squared. So I'm going to go ahead and write 3x cubed plus 0x squared plus x minus 3. Would you guys agree it's the same thing? Same as this one. Lovely. Do my official skate ramp and then write x minus 2. What number, let me try that again. X minus 2. What number do I have to multiply x by in order to get 3x cubed? X squared? Is it just x squared? 3x squared? Good. 3x squared. So x times 3x squared gives me 3x cubed. Now negative 2 times by 3x squared gives me negative 6x squared. Good. Now once again, what are we doing? What operation? Subtraction. So 3x cubed, take away 3x cubed gives me nothing. 0x squared, take away negative 6x squared gives me, sorry? Negative? Positive 6x, good. Positive 6x squared. I'm going to bring the x down. What number do I have to multiply x by to get 6x squared? 6x, good. Positive or negative? Good. I'm going to write 6x. And then I write, 6x squared. What's negative 2 times by positive 6x? Negative 12x. Once again, I subtract. What does that get me on the bottom? I get nothing here. Positive 1x. Take away negative 12x. What does that give me? Positive 13x. Am I done? No. We brought the x down here. Now I'm going to bring the last one, the negative 3, down here. So I get negative 3 over here. What do I have to multiply x by to get 13x? 13. Positive 13. So x times 13 is 13x. And then negative 2 times by positive 13. Negative 26. Now I'm taking away, remember? And I end up with negative 3 Take away negative 26. Positive 23 is correct. I don't know why I had to think about that for so long. Sorry, can I go any further? No, I can't. So remember, this term, or not term, this expression, multiplied by this expression, plus this expression, is going to give me that one. So I'm going to write that out in algebraic words. I'm going to write the original equation, 3x cubed plus x minus 3 is equal to x minus 2 times by 3x squared plus 6x plus 13. That's what we got over here. Plus 23. It's a huge concept to wrap your brain around. I understand fully well if we don't understand the first time. It's a huge concept. What I'm going to ask you to do is to watch this over the holidays and just practice. It is a very large concept. Do I have any questions as of now I might be able to answer? No? Okay, lovely.